you by thesis123.com. I learn and teach online.
Here's the next question, number 55. A rotating conductor of 1 meter length is placed in a radially outward about the z-axis magnetic flux density B of 1 Tesla as shown in the figure below. Conductor is parallel to and at 1 meter distance from the z-axis. The speed of the conductor in RPM required to induce a voltage of 1 volt across it should be dash. Okay, so here we are asked to find out what the speed is. Alright, let's write down what's given to us. We have been given the length L as 1 meter. We have the voltage given as 1 volt. We also have the magnetic flux density B as 1 Tesla. Okay, so let's start with voltage induced. Voltage induced will give us an expression in terms of electric field or induced electric field. So the voltage induced is equal to integral of EM dl. This is from 0 to 1. So the voltage induced is equal to the integral of the induced electric field. This is the induced electric field. Okay, so this gives us, now the voltage induced is 1 volt, that's what we have already. So 1 volt is equal to integral of EM dl. So we can write this in terms of EM, or the induced electric field is 1 volt per meter. Do you see that? So if the induced voltage is equal to the integral of EM dl, now this is in terms of the length with respect to the length. So we write EM as 1 volt per meter. Okay, so that's our EM. Now EM in terms of velocity. Now we will have to write it in terms of velocity. I'll explain why. Let me write it here. Okay. Now we need the speed as n, and n in terms of angular velocity is 60 omega by 2 pi. How do we get this? We get this from the formula omega is equal to 2 pi n by 60, right? So the expression for n would be 60 into omega by 2 pi. But we need what omega is. So omega can be found from this expression. Omega is equal to V by R, where V is the velocity in meter per second and R is the radius of the path. Now V can be written in terms of EM. EM is equal to V bar cross B bar. Now this is the usual notation. So these are the expressions with which we will find out what n is. So we have now written the expression for voltage induced in terms of induced electric field. So we found that EM is equal to 1 volt per meter. Now using this expression here, we will get what V is. So V is the radius of the path times angular velocity. So EM, I'm going to use this now here, okay. So EM is equal to V bar into B bar, right. So this is 1 volt per meter is equal to V into 1 Tesla. So V is equal to 1 meter per second. Alright. So from this expression here, this angular velocity is equal to the velocity for meter per second divided by the radius of the path, we get r is also 1 meter according to the figure given to us. So, r is equal to 1 meter, v is equal to 1 meter per second. That gives us omega is 1 radian per second. If v is 1 meter per second, radius is 1 meter, so that gives us an omega of 1 radian per second. So, we have omega, v, r. Now, let us see if we can substitute here. Oh, we just need omega here. So, n is equal to 60 omega by 2 pi. 60 into 1 radian per second divided by 2 into 3.14. So, the speed would be 9.55 per minute. So, this is the final answer here, 9.55. 9.55. Well, I hope this has helped.
Thank you for watching this video. For future videos, please click here to subscribe YouTube channel. Visit our site thesis123.com for free student project or research ideas and online training. Follow us Facebook, Twitter, Google+ and Pinterest.